Hello, hello. Hi, hey there. Hello, here to the stream. It's just variety. And yes, you called it new logo. And not only that, you can visit the YouTube channel to see that the banner has changed as well. And if you squint really good, you can see at the bottom right corner of the screen there should be the Just Variety watermark, which is my signature. So there you have it. Please do not take it because you'll be able to take some of my document stuff. Anyway, I proceed to draw it. And yes, this on the right side of the stream is actually like my scratch paper for doing these math competition sample questions. And yeah, I guess I should introduce the stream's gimmick as well. For today's stream, we will be trying out some math tournament questions, or specifically math tournament sample questions made by the University of North Georgia. I will put a disclaimer though how the math questions that I'm familiar with are mostly from the Philippines because I'm a Filipino math competition player. So I'm not sure if I'm going to be up to date with some of these questions, or even if I'm on their level, because this being from a different country, it might be different curriculum, different difficulty, and me just graduating high school. I didn't know why I skipped college. I was about to say that I'm not sure if these are college level, but it mixed up with my head thinking. I don't know if these are high school or college levels or post-college levels, but who knows? Based from the picture, it looks like it's also for students. Yeah, our commitment to our students, faculty, and staff. So I think I can. Oh, it's a military college. Okay, but yeah, I guess I could assume that this stream or these questions would fall I guess between post high school and pre-college, I would assume. Hopefully it's not too difficult that I don't know what to do. But yeah, this on the right side should be my scratch paper, and yes, I will turn pages on the scratch paper later. Like for example, if I already filled up the entire page, I'm just gonna whip up a new one and then keep writing. But really, I just added another layer. So I think that's what I'm gonna do. And usually for math tournaments, there should be a timer, but I won't time myself. And I've been thinking about this earlier if I should or shouldn't time myself. And ultimately, I decided on not timing myself so I could yap. Seeing as how I am a streamer, or I am streaming, I need to yap. So I won't put a timer so I can yap. And yapping gives me the benefit of 1, being able to think for as long as I need to, 2, walking you through my process, 3, just casually chatting. And another thing that I was thinking about earlier is that in math competitions, or in any competition usually, music isn't allowed. But again, this is a casual space, it's a stream, so I'm whipping this out. Hololive Music Studio, Jazz Mix, so credit goes out to them. You can see it on the top left corner of the stream. So yeah, without further ado, I also, this was kind of just a coincidence, but I took some, what is it called again? I took some soda earlier before streaming. That was kind of unintentional. We just had some lying in the fridge, so I drank some. It's not necessarily to give me sugar or to make me energized to do these sample questions, but it's a nice kind of homage to when I used to go to competitions back then. Because when I used to go to competitions, sometimes I'd drink soft drink or just eat something that I like. Not because I need the sugar or anything, because there were also competitions where I don't necessarily change anything with what I do. I just head straight into it, the competition. Oh, so you don't drink caffeine. Actually, me too, but not all the time. I sometimes drink caffeine. Not all the time though. Obviously, now is the example of the not all the time. I drink caffeine every once in a while, but not always. I'm not one of those people that need like coffee every day. I just go about my day and do the stuff. If I crash, I crash. If I burn out, I burn out. But yeah, sometimes I do like have a sugar crash, even though people said that it's a myth, apparently. Not sure. But let's head straight into this. I'll tackle the math questions one at a time, starting off with the oldest one, and I'm probably not going to finish all of these questions, but we'll try. And what I'm gonna do is answer all of the test questions first. I guess I should have also prepared like numbering my stuff. But yeah, I'm going to take this I guess 1 year at a time, with 2 tests, taking both of them at the same time. And then after taking on both tests of the same year, we're gonna be checking the answers for that year, for those questions. So yeah, we're starting off with 2023, and then up next is 2019. Interesting. Probably because of the pandemic. But also interesting is how there's no 2024 and 25 yet. But yeah, enough stalling. I'm kind of nervous because I don't usually get nervous doing any competitions, for that matter, or at least recently. Because when I first started out going to competitions, obviously there were a lot of pressure and I was really nervous and scared because I might not do bad. But after a lot of times of me just joining every competition I could, it started to desensitize me how, oh yeah, there are people, I'm gonna be competing against them. If I win, I win. If I don't, I don't. I obviously want to win. The pressure could be coming from me wanting to win, but I'm just not gonna get pressured. Like, I experienced this so many times that I know what I'm here for, I know what I want to do, I know my opponents. So yeah, just go into the competition and do that. But this time is kind of different because I'm in a different medium, I'm in a different environment. I'm with my stream chat. Oh, and another thing, no backseating. So once I open up the test PDFs, I won't be looking at chat for a while. I might cherry pick some messages, but if it's backseating, I won't look nor read it. So yeah, I wanna face this with just variety sense. Let's see. Let's see. Well, I think I am good. I've won a decent amount of competitions back in my day. Says back in my day as if I didn't just graduate from high school a couple of days ago. But yeah, starting off, the 26th Annual Mathematics Tournament, Morning Component. Good morning. Good morning. It is morning here in the Philippines right now. Please do not open this booklet until given this signal to begin. There are 40 multiple choice questions. Answer the questions on the electronic grading form by giving the best answer to each question. The scoring will be done by giving 1 point for each question answered correctly and 0 points for each question answered incorrectly or left blank. Thus, it is to your advantage to answer as many questions as possible, even if you have to guess. If there is a tie, question number 29 will be used again as a tiebreaker. This test was designed to be a challenge. It is difficult and you may not have time to complete all questions. Do not worry if you are unable to answer several of the questions. Instead, we hope that you will obtain satisfaction from those questions which you are able to answer. You may write in the test booklet. You may keep your test booklet and any of your scrap papers. Only the electronic grading form will be collected and graded. Good luck and do not open until signaled. I'll take good luck as my signal, so thank you. We're starting the imaginary timer that I'm not gonna be doing. Oh, actually, I should also widen this probably. It's just Krita, by the way. I just literally opened up Krita. There we go. So I have more space to see my notes and stuff. Um, you know what? Sure, I'm gonna put it here actually at the bottom right corner of the screen. There we go. So let's see, our first question. I'm gonna zoom real quick. There we go. So our first question. You may write on this test booklet, only the Scantron sheet will be graded. Correct answers are awarded 1 point. Incorrect or blank answers are awarded 0 points. I just realized I might have forgotten posting my live now. I didn't forget, right? Yeah, I didn't. Good. I'm kind of getting nervous already. You can clearly tell. Okay, like this, and I'm gonna monitor the stream as per usual. There we go. Mute this and then tab this. Okay, now this is where the actual solving begins. Okay, so compute the limit of this function as x approaches negative infinity. Crazy. One thing I could probably do is simplify, but I do not know how to do that. I'm already in a pickle and it's just the first question. Insane. Yeah, I should probably also make my brush a bit smaller. So I'm just copying the question right now. That's not -8, negative infinity of x squared times sine x plus cosine cube x all over, oh my gosh, x squared plus 1 times x minus 3. Immediately, something that popped up into my head is to simplify the denominator. Right? Okay, so limit. Let's probably simplify this first. It's gonna be x cubed. Okay, wait. It's gonna be minus 3x squared. And then plus x. And then negative 3. There we go. I think this is okay. I'm immediately lost. I'm not even gonna lie. I can't even like find a way to extract x squared from here. We can probably use analogies to work the numerator out and the denominator out. See if it converges or diverges. How would I tackle this? Okay, since you're squaring this, the infinity is gonna be positive. This is gonna be infinitely big. I don't think the answer is does not exist. We could always just randomly guess. And I guess I should have like the list of my answers somewhere. I forgot to do that. But yeah, let's take all of these, move them just a bit here. There we go. And then here's our numbers. Okay, number 1. Negative infinity. This is also going to be infinity. Negative infinity minus 3. This is basically negative infinity times infinity, which is negative here. This is going to be positive. The thing is, I don't know how to tackle the trig functions while it approaches infinity. There are no one answers as well. This is tough actually. Okay, I might have put myself in a pickle. I have no idea what the category for this is. I should have probably chosen a different test for this one. I do not, Ezer. But yeah. Also, please be noted that I'm gonna try to not look at chat as much while I'm doing the test, just to prevent potential backseating. I honestly have no idea. Negative there. I'm so lost right now, oh my gosh. You know what? I'm just gonna guess. Since the denominator is already negative. X dips though. Cube that also. I'm just gonna say -2 because the denominator is negative. Okay, and then I can probably remove this already. There you go. Okay, then what's next? Number two. Let T be the measure of the central angle. I'm not good with circles. I should have probably lead with me saying what I'm good and bad at as well in math. I'm not good with circles, believe it or not. Even though trig is probably one of the most fun branches of math to like play and mess around with. But yeah, T is the measure of the central angle AOB. The circle, the segment AC and BC are tangent to the circle. Tangents, oh my gosh. I remember there's a rule for this, but I don't remember what it is though. At points A and B, the triangular region ABC is divided into regions outside the circle whose area is GT, and the region inside the circle with area FT. Compute limit. Oh my gosh. ST equals to 0. I could probably do the cheap method of just using negatives. Or no, using the approaching method. I forgot what it's called. I'm at a loss of words, oh my gosh. I forgot the law for this, or the rule, postulate. I don't remember what it's called too. That's the worst part, but yeah. Let's see what we can cook with here. And here's our scenario. Internal angle is measured by T. This is center. And then it's AB. This is the triangle. And then this is GT. This is FT. This is C. Okay, well. Oh, whoops. First of all, what comes to my mind is using the formula for area. Yeah, it is area, right? So it's gonna be pi r squared divided. It's gonna be theta, or in this case T, over 2 pi. Okay, we can cancel pi. You can just say it's T over 2 r squared. Yeah, I think this is a good way to represent it. Wait, what am I thinking? Wait. The triangular region ABC is divided into the region. Oh, wait, so we're computing this actually, not this entire sector. I forgot how to take this though. I'm cooked. Okay, but this is for the area of the entire segment. I don't even remember if it's called segment or sector. I think it's sector, and we just need the segment. The segment is this. Sector is the entire slice. Okay, so we need to find a way to remove this actually. I feel like I have an idea, but I don't know how. I'm also not searching. But right off the bat, what I can think of is using the 1/2 AB sine C trick. So what would it be though? This could be the sine C, the T. This would be lowercase c. Wait. Let me think about it real quick. Okay, so this is lower C. Okay. Maybe doing a math competition stream might not have been my best idea so far. I could just arbitrarily name these, right? So yeah, regardless, it's gonna be r squared. I think r squared, and then 1/2, and then sine t. I think I can remove both of these now. Okay. And then let's move this up here. We're gonna subtract this if I'm not mistaken. Yeah, I think we are. I legit forgot how to take the area of the segment, but we are trying anyway. So this is the segment, should be. I'm not even sure if I did this one correct. And speaking of that, you could remove this. Like, yeah, because this part, the t/2 pi, should be the percentage of the circle that we're taking, and then pi r squared would be the area of the entire circle. So taking the percentage of the entire area of the circle would give you the area of the percentage that you're taking with respect to the angle that you're taking. Oh, whoop. There we go. Okay, so let's subtract these from each other. Now this is what I've been wanting to have in competitions. A scratch paper that's super easy to manipulate. With a lasso tool, an undo button. But yeah, I'm immediately lost. We can extract r squared, 1/2 r squared though. 1/2 r squared. So that just leaves t minus sine t. I feel like this function right here is pretty familiar. Yeah, now this is the area of ft. Let's just label it ft. And then, since we know that ABC is a triangle, we could probably do something with that as well. Oh, whoops. Let's remove this. Now, how do we get GT though? GT. Wait, first of all, what's sine 0? I can't remember. I'm gonna use the hand trick. Cosine. Sine. Sine 0 should also be 0, right? Yeah, it is 0, okay. So, sine 0 equals 0. Oh, but I used radians here though. Oh, but 0 in radians and degrees are the same anyway. Doesn't matter. Sine 0 equals 0. Regardless if it's degrees or radians. How about for the triangle though? Yeah, I need to visualize this more. Because what I have in mind right now is that this is a quadrilateral, and I think these opposite angles should be congruent, if I'm not mistaken. But I'm almost certain that I'm mistaken. Yeah, I think I am mistaken. Oh my gosh, so I have no way to figure out the angle here. But no, these two would always be would always have the same angle. So that leaves these two also having the same angle. Okay, so I think I can come up with something again. So GT would be whatever the triangle's area is, area of the triangle minus ft. So ft would always be bigger, right? Wait, what? No, GT would be bigger. Yeah, GT would always be bigger, I think. This is so bad. I'm so bad at this. Wait, but this cancels out to being 0 anyway. Oh, but wouldn't area? The answer is only 0, -1, or 1. Excluding does not exist and none of the above. Oh my gosh. This stream is just gonna end up with me trying to guess every question. This might not be made for my level, so... But I feel like I should know how to do this. It's just I forgot how to manipulate circles. I could do the like triangle trick again. So this is angle C. This is C. And then A. Wait, no. Arbitrarily A and B. But I don't know the length of these though. I could have probably figured that out if I know how to manipulate tangents and circles and all that. But I don't. But we do know this. We could say... Well, if we directly replace t with 0, 0 would just be... This would equate to 0 and then it's just gonna leave the area. And if we subtract 0 from a positive number, which is the area, which would never be... I assume would never be... would never be negative, then I think it should be 1. It could also be none of the above or does not exist. The does not exist is kinda iffy, but I think I'm kinda right on this one. My guess is probably right. That's the only thing I'm going off of. Anyway, next question. Oh my gosh, we're so bad at this. I'm so bad at this. So compute the following limit if it exists. The limit of the absolute value of x over x subtracted by 5e to the x plus 6. Wait, oh wait. Couldn't we just differentiate this though? Oh, but we can't. The absolute value is stopping us from differentiating it. I'm gonna try brute forcing this actually. We might be able to get it. Let's try 0.1 and then just see if it approaches anywhere. This will... Okay, the left side would always be 1 regardless. Or the fraction. Minus 5e to the x plus 6. Interesting. Well, we could combine like terms and say it's gonna be 7 5e to the x. But that doesn't really take us anywhere though. If we say that this becomes 0, then this is 1 and then 5. It should be 2, but there's no 2 answer. I'm losing it. I just cracked my back. Going to the gym has been taking a toll on my muscle soreness. Oh my gosh. That back crack was so fruitful to me. But yeah, I'm not even sure if my mic picked that up. That was kinda something else. Oh my gosh. I'm lost actually. I might be going at this from the wrong perspective. I don't know what to do though. Can't even differentiate it. Because again, the absolute value is stopping us. Well, 2 is closer to 1, so we're guessing 1. We're guessing A. Okay, next question. This might be too hard for us. I'm only now starting to realize that. Suppose A and B are real numbers such that the limit of sine squared of x over e to the ax minus bx minus 1 is equal to 1/2 as x approaches 0. Determine all possible ordered pairs of A and B. I can't do this. Wait, B? A and B are real numbers. Where does B show up? Oh, bx minus bx. I didn't see that. Determine all possible ordered pairs. Couldn't we just directly replace them? Sine squared is always going to be positive. Sine squared of 0 is still 0. It's gonna zero out. What if it's 2? So e e squared x. It's gonna be 1 minus b. How about b? B becomes 2 minus 2x. Oh no. Huh? No, it also zeros out. It leaves... Oh my gosh, I'm not doing good here. Chat, help. X is 0. It's gonna be 1 minus 0 minus 1. It's gonna be 0 over 0. I could probably derive the top and bottom sides, but I forgot how to derive sine squared. Like, actually. Let's start deriving the bottom part first. Even though I will admit that I forgot how to derive it. I should have done more reviewing here. Okay. How do I do this? I forgot, man. I'm gonna need backup. Chat. Help me. What do I do? Okay. First of all, let's probably write it down. D over dx of sine squared of x all over d dx of e to the ax. We're considering a and b to be constants right now. Dx. Oh no, minus 1. There we go. Okay. I don't know where to go from this. First of all, I need to remember how to derive e. It should be eax, right? Multiplied by how? Probably just a, I think. I'm so cooked, chat. P. And then that zeroes out. And then sine squared. What? I don't know though. Let's try this probably. Sine 2x. I'm gonna write this a lot more neater. There we go. Sine 2x. I think this works. So let's try working with this. E to the ax still messes us up, by the way. And sine 4 doesn't help either, because I don't know what that is. Microwave noises. Two. This is gonna zero. Wait, this also zeroes out. So sine 0 is gonna be... What? Okay, let's try doing this. Substituting x for 0. Then that makes it so that this is sine 0, which is 0. This zeroes out, becomes 1 times whatever a is. In this case, a is 2. Oh, but no, sine 0 already zeroes us out anyway. Wait, this zeroes us out whatever we do, actually. Huh. Maybe one of these rare times, the answer might be E. I don't know. It might be more useful if we had someone like Rick here help me with this. He's actually beating me up. Okay. Zoomer just asked our group chat about something, about one of our videos that we might be doing soon. I'm gonna reply to that real quick now that I've actually said it on stream. I need to not read this out loud. Okay, there we go. Just confirm something for when we meet up, me and my friends. Hopefully we get to record actually. Because I'm kind of getting nervous. I think we would also have new people, new faces if we film that video. Because we did invite other people as well, so it's not just gonna be us. So expect to see new people, but yeah. Moving on to here. Compute the limit of the natural log of the absolute value of x minus the natural log of the absolute value of sine x as x approaches 0. I don't know. Wait, if x is 0, wait, is this even like possible? Okay, I might need to find a different math competition, a set of math competition. You know what? I'm gonna remove this real quick because this is actually beating my butt. It's not gonna be fun if I'm just getting beat up by all of these questions. But yeah, let's search math competitions, questions and answers for let's say high school, even though I just graduated from high school. Where can we find some? How about here? I'm not. This one is from Louisiana. I'm not sure if it's for high school students as well. Let's see. I'm checking it out right now. This one is getting my butt beat. Oh, but actually, I want to check out the answers first. The answers of the only 4 questions that we took. And we got none of them right. Insane guessing game. Even in guessing game, Rick is better than me at that. But yeah, let's look at this. How about this? Which of the following would be the best response to... What? What is this? Oh. That's kind of cringe, but I understood it. You know what? Like, for the heck of it, because this looks so strange. I'm tempted that this one is the one that we should do. Because look at this. Look at the first question. And all of the rules apply, by the way. All of the things that I've said earlier. But yeah, look at this. Which of the following would be the response to the square root of -1 times 2 cubed times the sum of pi? Question mark. And the options are, and then my wife left me, but it was the wrong formula, so we turned to the right. But I thought the contest was today, and it was delicious. At first I was like, what the heck is this talking about? What is this competition on about? But then I realized the square root of -1 is the imaginary unit I. And then I think you could see where I'm going with this. 2 cubed is 8, so that leaves us with I8, and the sigma symbol is for summation. So I8 sum and then pi, I8 sum pi. What would be the best response? That's gonna be E. Okay, this is what I get for choosing an easier set of questions, but oh well. At least we can answer it, unlike earlier where we were just guessing all of it. Anyway, number 2. On a certain trading day stock blank, stock brand X declined by by $0.27 or 4% of its value. What was the value of the stock at the end of the trading day? So we're missing base. I remember the triangle for this one, which was this. I remembered it because it's blue, red, mixed becomes purple. We don't have the base, we have the percentage, and we have the rate. So that's gonna be 0.27 over 0.04. I'm kind of lazy to compute this right now manually, but I am quote-unquote in a competition right now, so I don't have much of a choice. This is 6, 24, yeah. 24, that leaves us with 30. This is 28. 6.7. I don't even need to do anything else because there's only one answer that starts with 6.7. And the answer to that will be A. Okay. Not that hard. I need something in between the last test that we did and this one. Because I think this is too easy. I guess 40 coins consisting of dimes and quarters. If the dimes were quarters and the quarters dimes, he would have 90 cents more. How many quarters does he have? Wait, so originally he has 40, but if we swap out this stuff, it becomes 130. Wait, this is kind of difficult actually. Now I'm stumped. One of the main things is the reason for that being I don't know what the heck a dime is. I'm Filipino. Dimes. A 10-cent coin. Okay. I'm gonna write that down in case I forget it. So a dime is 0.10, and a cent should be self-explanatory. Cent being the etymological origin of the word percent. Centavo. Century being a unit of the hundredths or hundreds. So that's gonna be 0.01. Okay. Mike has 40 coins consisting of dimes and quarters. If the dimes were quarters and the quarters were the quarters dimes, he would have 90 cents more. Wait, what? How many quarters does he have? Wait, it's not actually asking. Wait, no, 40 coins is a misnomer. He has 40 coins, but not necessarily 40 cents. Or maybe that's a mistake of this, though. What? If the dimes were quarters and the quarters were dimes, he would have 90 cents more. What? How many quarters does he have? Interesting. Wait, what? Quarters? I just realized that. Dimes and quarters, there's no sense. Oh, but quarters should be 25, right? I'm just gonna like write quart, yeah, that's okay. And I'm going to assume that this is 25 cents. 25 coins consisting of dimes and quarters. So 10s and 25s. If the dimes were quarters and the quarters dimes, if these two swapped, he would have 90 cents more. But what was the original value though? I feel like I'm thinking about this more complicated than it should be. I'm gonna skip the question for now. Let's probably go back to that later. One of the tricks I've caught, one of the tricks I've started to learn while I was doing competition stuff, just to skip the difficult questions. That should be obvious, but when I was younger, like way younger, it wasn't. I just tried headbutting myself to every question I saw and then proceeding to the next only after I finished that. But yeah, given that the base log of 2 is 0.30103, rounded to 5 decimal places, how many digits are there in the decimal expansion of... What? Okay. Clearly, it's telling us to log base log, default log 2 to the 2019. To that, we can apply this rule where the exponent exits, leaving us with 2019 times the log of 2. Now this is a bit harder because now we have to multiply this to each other. How many digits are there in the decimal expansion of... Oh. Okay. How many digits? You know what? I'm gonna brute force this. There's probably a much smarter way to tackle this, but I just don't have the capacity right now to think about whatever that might be. You know what? Sure, this is okay. 9, 18, 27. This is 2. This is 9. This is 0. This is 27. And then 3, 0, 1, 0, 3. Why am I even thinking? This should all then be zeros. And just double of everything. Double it, give it to the next person. Here we go. And then we have 7. No, not 6. 5, 9, 7, 7. What is this? Also 7. I play Holocure Casino. I should know what this is. I should be able to do quick addition like this. But yeah, and then there are 5 decimal places, so it's gonna be 607.707. No, 607.77957. There are. Wait, how many digits are there? What? There are only 8 though. What? I guess it kinda got confused. I wonder if we round up or down, but I'm just gonna follow the if it's 4 below, then you round down. If it's 5 above, you round up. So that leaves us with 608. The answer should technically be 8, no? Because it's asking how many digits are there, not necessarily what the answer is. Whatever. Anyway, next question. Wait, that I put D on the wrong number. If this was a competition, I would be toast without correction tape. Even if it was allowed, I'd be toast. Anyway, the graph of the equation x squared minus 8x plus y squared minus 6y is equal to 75. It's a circle with what center? Oh, so we're just trying to find the center for this. We can do that. Okay, it's starting to pick up steam, the questions I'm noticing. So that's pretty good. It's right down my alley, but not really because it's still somewhat pretty simple. We could just keep the 75 on the right side. Let's just keep all of these here. What we can do... What can we do? We could square root stuff. I forgot how to do this. Oh my gosh. Oh no. Oh yeah, we need to bring this back here. Like there's no other way, I think. And then with this, how does it go? So it's x minus, what is it? H squared plus y minus k squared equals the radius squared. You could remove the 25 here and just leave it with 3 times 25, and then the right side would be 5. Yeah. You know what? I'm tempted to do that right now, so I will. Let's say... I didn't remove that. Let's say that we're subtracting by 3 because we left the 25 here, so it's in the form r squared, r being 5. How do you complete squares again? Oh my gosh. Wait. Chat. I'm just kidding. No backseating yet. I can figure this out. Watch. 2. Okay, what 2 numbers you add becomes negative 8? There's just too many. But when you multiply, it would also give you an actual answer. Okay, maybe leaving the 75 on the other side was the correct thing to do. So let's do this again. Could also try going for 6 again. Oh, but couldn't we just divide actually? Divide by 2, so it's gonna be this. And then, no, wait, no. X minus 4, right? This works out, right? Because if you square this, it's gonna be x squared minus twice this x, and then this would be plus 4 squared, 16. Okay, 16. And then I guess we could do the same thing here as well. This is me figuring out how to extract the like one of the ways how to express a circle for the first time in a long time, because this was taught to us. I didn't listen because I already knew, and then I forgot about it, and now here I am. I'm like a rusty old person that forgot how to do the thing that he liked doing. Yeah, I think this should also be how you do it. So this is twice that with y, not x, and then square this, so it becomes positive. So 16, 25, that leaves 50 to the other side. Oh wait, why did I even do all of this? We just need to find the center, which is 4, 3. So the center is 4, 3. What am I doing? I got too lost in the sauce. Oh my gosh. So the answer is 4, 3, B. I did all of that just to realize that I wasted all of my time. But that's usually how I do it in competitions anyway. I try figuring something out that doesn't need figuring out, because it's just a step of a way there, not really the finish line. So I messed up. Wait, did I number the stuff wrong again? I didn't read question number 4. Oh my gosh. I missed it completely. No matter, we can move all of these down. Trust, we're not cheating, absolutely. You can obviously do this in competitions. I'm just kidding. Unless it is allowed by the competition itself to manipulate reality in the fabric of the paper itself, and then select it and then redrag it to a different set of answers. But yeah, apparently I didn't read question number 4. The equation y minus x equals a times the difference of the square of x minus h has a graph of a parabola with vertex hx. I don't remember my conics as well. Suppose a is greater than 0. A horizontal line 1 unit above the vertex. Horizontal line 1 unit above the vertex, okay, makes sense, intersects the graph at 2 points. Huh? Find the distance between these 2 points. A horizontal line 1 unit above the vertex. Well, first of all, it's gonna be positive, right? Because the right hand side isn't negative, so it should look like this. And then I assume this is 1 unit. Then there's a horizontal line that intersects 2 points of the parabola. Assuming a is greater than 0. Find the distance between these 2 points. Oh, it's like I can probably figure out what a is based from the 1 unit above the vertex, right? Shouldn't it just be 1 though? Because if it's 1, then it's just gonna be the default thing. Huh? Okay, so I'm gonna think about it if y was 1. Because let's set all of this in the origin. And if we set this in the origin, then k and h are irrelevant. This leaves us with y equals ax squared. And if we say that... Let's say that a is 1 for now, shall we? But that just leaves us with a default y equals x squared. So 1 unit above would mean y is 1. 1 equals x squared. X equals plus minus 1. Yeah? There are no answers like that. I'm cooked. Wait, how do you do this? I forgot how to work with conics. Oh, whoops, I didn't mean to crop. Okay, let's remove all of these. I can probably logic this out. How would A affect it anyway? So let's think about this. We have this. We have this, right? Let's just say this is y equals x squared for now. We're figuring out stuff again. So this is 0, 0. At 1 on both sides, negative 1 and 1 here, it's gonna be 1 on both sides. Yeah. And then at 2, at the respective 2's, it's gonna be, let's just say here. And then this is 4, also 4. What if you made it so that y equals 2x squared? Now everything should double. So it's still 0, 0. But at 1, it becomes like, it becomes 2, right? Okay, so something like this. And then this is 2. And then at 2, it's 4 times, and then 8. So increasing this makes it closer. But what's the distance between these two though? These two. Okay, so this, the distance between this. Wait. Wait, what? 1 unit above. So, oh, so this doesn't change. This becomes closer and closer to the y-axis. But this doesn't change. I was kind of thinking, wouldn't it just be 2 units from negative 1 to positive 1? But no, okay, so the horizontal line doesn't change. It's always 1 unit above the vertex. What? Okay, 1 unit above the vertex. The vertex is HK. I know that much. Increasing A makes them closer. So A is inversely proportional to the distance. So right now we have either D or E, because both D and E have a inversely proportional to its final result. What I'm now curious about is why the 2 root A though? 2 square root A. 2 square root A. Well, let's see if it works first. So this, the answer should be 2. And A is what right now? A is 1. So 1, 1. The distance is 2 units. Okay, that's good for now. What if here? What if here? It's just gonna be 1 unit still. Oops. I accidentally dropped my mic. I'm sorry for that if that was kinda shocking to hear. Just a sudden boom. So sorry to headphone wearers or anything of the likes. But yeah, let's input y as 1. This becomes negative, or no, 1 over 2, a half. And then it becomes plus minus the square root of 2 under 1. If we say that y is 1, because that's the height of the horizontal line, 1 unit above the vertex. It's just gonna be k plus 1 always. Our k right now is 0, so it's so y is just 1. I didn't know your game. Math competition test. Apparently, I'm getting smoked right now. We already spent an hour doing math competition stuff. I probably shouldn't have drank the soft drink. Now my brain is going all over the place thinking about different stuff. But yeah, okay. So it's plus minus 2. Wait, it can't be negative because we're taking a look at distance. So it's 1 over square root of 2. I don't know what the square root of 2 is. This has gotta be small, right? I'm also kind of sure that there's a question that said square root of 2 here. No, it's just the log of 2. Log of 2. What is this? It should be 0 point something. No, or 1 point something. So this becomes smaller actually because it's 1 point something and 1 is smaller than 1 point something. So the ratio between them would be 0 point something. Okay. So increasing A lowers the distance as well. Why 2A squared though? 2 squared A, I mean. And why did I even do this? I forgot why I did this. I guess if we increased A, we're looking as to what happened. Well, A right now is 2. Still have no idea. Oh, we were looking at if it would be 2 over A. In this case, wait, 2 over 1. So yeah, 2 over 1 works here, but 2 over our A here is 2. If we did 2 over 2, this doesn't work because it says 1, but their actual distance should be 0 point something. So yeah, 2 times the square root of A, even though I don't know how it works, looks more right. That's just what I'm going off of. And yeah, that's basically the power of just going by it using analogy. I'm not even sure if this is correct, but I'm going with it because I don't know how it got 2 square root 1. And yeah, that's usually how it goes when I don't know the answer. But that happens like 70% of the time. Well, to be fair, the competitions I join in are somewhat difficult. Some even levels way above mine. But yeah, we're now at number 7 actually. So how many 4-digit numbers between 7,000 and 8,000 are there for which the thousands digits equal the sum of the other 3 digits? Buh? Okay, so immediately you start off with 7. So how many combinations are there to add up 7? Well, we can do 0 plus 0 plus 7, 0 plus 1 plus 6. This is gonna take so long. There's probably a way to like solve for how many combinations there are, but my brain is not thinking right now. The brain is not braining. I hate that joke. 4 plus 3. Alright, at this point it just swaps. So 4 of these, so 8 with these 2 sets. So there are 8. There are 8 when it comes to these 2 changing. Yeah, I think so. It's showing a variety of answers though. Like from the low 10 and 24 to the higher 36, 72. But I am getting this right? How many 4-digit numbers between 7,000 from 8,000? So 7,000, 7,001, 7,002, and up until 7,999 and 8,000 are there for which the thousands digit, which is 7, it's always just gonna be 7, equal the sum of the other 3 numbers. So yeah, we already have 8, and I don't think it's gonna be 10, because there's no way the remaining other combinations only have 2. Okay, so let's take a look at this. If there is a 7, then there are only 3 ways. I'm gonna like write ways. There are only 3 ways if 7 is already there. You can arrange 6 and 1. Like how many times? 1, 2, 3. 3 times 2, 6 ways. Then that should also be the same for the other combinations, which are 5, 2, 4, 3. Yeah, just these. Then there are 6 as well. I'm just gonna drag this down. So 6, 12, 18. We're already at 21. We're on our way to be 24, but with 3 number combinations, I think that might actually put us at 72 with how many there are with that. Because what we can do is 1, 1, 5, 1, 2, 4. This is so difficult. I feel like I'm starting to realize a pattern somewhere. 4, 2 is next. Okay, first of all, how many ways are there to organize this? This one, it has 1, 2, 3. Okay, 3. This one has 1, 2, 3, 4, 5, 6. This has 6. This has 3. So whenever they're repeating, it's only 3. So we have 6, 12, 18, 24, 33 right now. And we still haven't even done this. How it could be 2. It can't be 2, 1, 4. It could be 2, 2, 3. Yeah. And this already puts us at 3. It goes over 36. There's 72. Oh, but there's none of these though. I kind of want to see if it's none of these. Literally just to check. But I already think it's D. I have my mindset on that. There are only 3 ways to organize this. Because 2 repeats itself. 2, 3, 2 are also the same. Oh wait. Oh wait, no way. Is it 36? There are only 36 ways? What? That's kind of interesting. Because if we... There's no more left. 2, 2, 4? If we make it 2, 4, then the other one would be 1, and it's already part of this. And anything 6 would just mean that the other number should be 1, and there's already 6 ways to arrange that. That is so interesting. So there are 6, 12, 18, 24, 30, 36 ways. That's so cool. Okay. It was such a good thing that I checked. Because I would have unironically answered 72. That is so interesting. That's so pretty. That's so cool. That's also one of the things that I really like whenever I join competitions, is having my like expectations blown. Oh, didn't mean to go there immediately. Having my expectations blown and then just be, oh, so that's how it works. That is like always a mind blow. Like, oh, so that's how you do it. I get it now. I know. Now I know. I'm like hacking. Anyway, I just checked something real quick. Checked up on the nerds again, the friends. Anyway, number 8. If S is the set of all points in a plane whose distance to the origin is twice the distance. I immediately need to grab this. I'm so confused. Okay, so S is the set of all points in the plane whose distance to the origin is... Bruh. Twice the distance to the point 4, 4. So you mean 4 square root 2? So the distance would be 4 square root 2 thanks to Pythagoras. Then S is a... What? Wait. If S is the set of all points in the plane whose distance... Huh? Like, S is a set. Oh, if... What? Twice the distance to the point. So, like... Oh, so 8. 8 root 2, right? Because it's twice the distance to the point 4, 4. And from the origin to point 4, 4, the distance is 4 square root 2. 4 root 2. If it's twice the distance, then it would be 8 root 2. If S is a set of all points in the plane whose distance to the origin is twice the distance... Huh? The empty set. Circle is the only thing that's coming to mind right now, because if all of them are equidistant, and we're like generalizing that all points are this specific distance to the origin, then that would kind of imply that we're looking at a circle with its center in the origin, because I'm kind of getting the tone here that all of the points in this plane are equidistant by 8 root 2. Then that's so. There's only one shape that's equidistant relative to its center. That's a circle. Circle time. The song. 9. What is the remainder when 2019 to the 4th divided by 7? Are you serious? Are you serious? I don't know what the trick to dividing by 7 is. I don't want to do this. I don't want to just brute force this, because I really don't know. I might actually just multiply all of this and divide it. What? I'm not even like thinking of any workaround from this. There's no thoughts entering my head right now. I have no idea how I'm gonna do this. You know what? Might as well brute force it. Since we're here, we're doing it. No way it's gonna take the entire stream, right? That's 9, this is 16, that's 7, 0, 4. And then another 2019. Oh my gosh. Like what? How do you determine if a number is divisible by 7? What if we just did this and hopefully it's the right answer? This is 61, 8, 56, 59. What is this? 56, right? Wait, what? No, it's not 7. Oh, it's 8 again. 56. What am I doing? I'm throwing. Okay, 3 is the answer here. I'm just gonna answer 3. I have no idea how to take that on. I used to know, but now I don't. Because back then when I was at a really large competition, there was one of the practice questions that was like this, and I learned how to do this, but then I forgot. I forgot how to do it. we could just look into how this works. So this is 9. 9 squared would be 81. 9 cubed would be 729. And then 9 to the 4 would be, I have no idea. Let's check. And 18, 26, this is 63, so 65. And then this would be the answer to 9 to the 4. If you've noticed, there's a pattern actually. If 9 is raised by the to the power of an odd number, the answer that you get is 9, or the ones digit is 9. And if you raise 9 to the power of an even number, what you get is a number that ends in 1. So maybe we can work with this. We divide this by 7, the remainder is 2. We divide this by 7, the remainder, wait, what's this? 7 becomes 4. This is 4. How about this? This is 1, 1, 0, 29. We could say 28. If it's 28, then it's gonna be remainder 1. How about this? We divide this by 7. 63, that's 9. That leaves us with 26. 21 should do it. 51. 51 is directly divisible by... Oh wait, I messed up, I think. Oh wait. This is 63. This leaves us with 26. 7, 14, 21, 28. So yeah, just 3. Leaves us with 21, 51. Oh wait, wait, that was right, what I did. Okay, 51. What's the remainder if it's 51? 7 divided by 51. I can't math right now. 49 works probably, so it's 749. Remainder 2. So I'm guessing this repeats again and again. So we have 1, 2, 3, no, 1, 2, 3, 1, 2, 3, 1, 2, 3. But since this is 4, I'm guessing that the answer should actually be B. I'm gonna be so mind blown if I'm actually correct on this one, because that's usually how it is. I remembered that whenever there are like exponent problems that just need you to identify something about the last digit, the only thing you need is to find the pattern of the first few digits, and that works most of the time. Like raising 4 to the power of whatever, I'm pretty sure there's also a pattern that forms. It would be easier to visualize this if I had my old notebook that had my competition notes, but somebody else has it, so I really can't read it right now. And graduation is already done. I really don't have any way to access that person, so I have no idea how I'm gonna get my notebook back. I guess I'll just call that person some other time. But yeah, I lend it to that person because they were also going to go to a competition, and they like asked me for advice. Oh yeah, asking Jay for the just math advice, just math tips. Anyway, question number 10. We're almost the way there. How many questions are there? There are 24 questions. Okay, we can probably actually finish all of these in this stream. I might not do another one because I'm starting to feel my head. And we already spent an hour 20 minutes. So I think with the remaining questions we can just burn through our remaining time. Oh, I didn't mean to press space again. Anyway, number 10. Figures A and B below are made up of congruent rectangles, each of which has perimeter 13. What? if the perimeter of figure A is 31, then what is the perimeter of figure B? That is honestly insane. Okay, so made of congruent rectangles, each of which has perimeter 13. Okay, I think this is just going to be a case of simple substitution. So it's like this, and then what? Like this. So what happens is we can label the rectangle like so, where the long side is x, the short side is y, and then we can say that 2x plus 2y equals 13, because that's the individual perimeter of each rectangle themselves. So that's pretty useful information, and now we just start counting. This is y, this is y, this is also x, and this is x, y, y, x, x, and this would be 2y, oh no, x minus 2y. I write y so bad. I thought for a second this was y. Or no, x. So this is x minus 2y because x is the long side and there are two y's blocking up the thing here. Oh, but wait, we could just simplify this to say that this entire thing is x. So we don't have to worry about these two anymore. But we'll check that later. And then this side would be x minus y. Okay. Figure A has a perimeter of 31. Oh boy. Oh, wait. We could actually try and figure out the measure of x and y right here, right now, probably. So let's add the individual parts. And this isn't helping, so I'm gonna make it a bit tidier. So this is rectangle 1 and rectangle 2, and then 2 rectangles here. Okay, that really didn't help. I'm just gonna circle out the stuff that I've already written down. So let's write x plus 2y. 2y is this. And then plus x minus y, which is already this. And then plus 2x, I guess, plus 2x plus 2y, and that's these ones. And then the x minus 2y plus x minus 2y, that's this one, and then we only have 2 left, x plus y. Wait, x, okay, wait, I'm like constantly brain farting right now. My brain is so stinky with all of these questions. I didn't mean to crop again. I was supposed to remove it. But anyway, that should be all of them. I'm gonna remove that real quick and then clean this up, because we can also do substitution later. Anyway, equals, let's combine all of the x's first. So we have 1, 2, 3, 4, 5, 6 x's. So 6x plus we have 1, 2, 1, 2, 3, 1, 2, 2y. There we go. And then this is equal to 31. That's this one. There we go. Just to have markers, and we can start substituting. We can say 4x plus 2x plus 2y equals 31. And since we know what this is based from this, we can substitute. we can say that the scratch paper is so messy. I swear when I am at competitions, my scratch paper isn't always this messy. But yeah, thanks to this, we can say that 4x plus 13 equals 31. So do a bit of properties of equality. We can say that, what's 31 minus 13? I can't believe I have to do this. Because this is the faster way we're gonna finish this. 18. Why did I have such a big hard time trying to figure that out? But yeah, so this leaves us with x being equal to, it's actually not a flat number now that I look at it, but I did add right? I don't think I did. Wait, I did. Now I'm getting confused, but 18 divided by 4, that's 4 point... Man, I don't want to... 4. That leaves... Let's leave 4.5. Oh my gosh, okay. So now we can say that x times 2... Oh no, x is equal to 4.5. So that's our biggest revelation. X equals 4.5. Now we can start computing stuff. We can also compute what y is now. Okay, I need to stop giving y. There we go, the x's. It looks like x. The x's as in x's. There we go. Not the... Not... I didn't mean to say... Not x's. I am getting so cooked right now. It's so hot in the Philippines right now. It's so hot where I am right now. I think the sugar is finally starting to crash down on me. Insert other just variety typical excuses, and yeah. But yeah, why? We can do this. 13 minus 9. That's equal to this. And this is 4, y is equal to 2. Very good, very good. Now we can check if this is true. That's 9. 9 plus 4 equals 13. Yep, we did all of this correctly. Now we can probably figure out what the area or the huge thing at figure B is. Like, what the heck is that? Okay, let's break this down again. Why don't we? Just gonna do the same trick that we did earlier, where we're gonna write down of the things that we noticed that are part of the perimeter, and then start counting x's and y's. This actually fits. That's crazy. But yeah, x is the long side. I need to remember. My figure looks so bad compared to the right side. But I am still looking at figure B instead of my own drawing. My own drawing looks so bad. This is x. This is y. X again. Y again. Y. There's probably a way faster way of doing this, but I'm gonna be honest, I have no idea. And this is x minus y. This is... What is this? This is y. This is x, the long side, and there's a little stub right here, so I'm gonna count that too. It's x minus 2y again. This side is y. This is x minus y. This is y. And this is x. That should be all of them. Oh my gosh, look at this behemoth. It looks like a heart. We're slaying the heart of the beast. But yeah, let's start from bottom up again. We have y. And then let's go counterclockwise. X minus y plus x plus y plus x. I sound insane. Plus y. Oh, there we go. Finally, something different. Plus x minus 2y plus x. Oh my god. Plus y plus x. Wait, I'm kind of lost. X, y, x. Okay. And then y plus x minus y plus x plus y. There we go. And then let's start breaking this down. This is so eco-friendly. Like, look, I'm not wasting any paper. I am using up electricity though. But yeah. At least I'm not using a lot of paper to use as my scratch. But whenever I am in competitions, I use the scratch paper that they provide us with very sparingly, so I don't waste it. Okay, so right off the bat, let's start with x. There are how many x's? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 x's plus 1, 0, 1, 2, 0, 1, 2, 1, 2. 2y. Okay, that's very useful to know. So that is 4. And this is how many? 4.5 times 8. Help me. I really can't think right now. 8, 16, 32, 36, 360. It's 364. And there are no answers like that. What? What? Wait. Now I'm actually kind of distraught. What? What did I do wrong? I got such a high answer. Oh wait, no, it's just 36. The answer is 40. I'm overreacting. My bad, my bad. I forgot the decimal point, chat. My bad, my bad. I might have got too lost in the sauce on that one. Anyway, that was fun. That was fun. Kinda tedious, but that was fun actually. It was simply counting. They really like that. Now it's starting. Now this quote-unquote competition questions are starting to seem more like how do I say it? It's starting to seem more like I'm just answering questions as opposed to challenging myself, because as far as I know, aside from the dime one, I've gotten most of them correct. Or at least I'm kind of confident that I've gotten them correct. This one, number 9 though, I'm not quite sure. But yeah, let's proceed and see how long this confidence takes me. How far this confidence takes me. Suppose x and y are positive integers such that the square of x plus y plus 3y squared is equal to 63. Find x. What? Okay. Why do I kind of feel like this question is deceivingly too simple? Can't be, right? Like, here we go. Squared. And then plus 3y squared equals 36. Oh, whoops. 36. There's not even a way to remove the y squared, I don't think. But yeah, let's start working with the obvious. This is 2xy plus y squared plus 3y squared. Then this gives us x squared plus 2xy plus 4y squared. Oh, maybe it's like trying to make it so that we compress this into a different square equation, a sum of square equation. But I don't see it though. Could be Could be what? Could be, it can't be 2 because this is 2. This is such a surreal feeling of me of me doing competition type of questions, or maybe just the fact that I'm doing math competitions while I'm streaming. It's such a new experience to me. Feels so different while all being familiar as well. But I guess that's just how I feel or felt when I started streaming. It's familiar to play games. It's quite unfamiliar to commentate while playing them. But yeah, what can I do with this though? It could also be negative. No, I don't think so. Because if two negative numbers multiplied, then they would give a positive. But if they added, they'd give a negative. Okay, then what should I do though? Well, both of them are positive integers. What can I do with that information though? Should we just like try inputting every number? I guess we should. Let's try. So let's say this is 1, this is 2y, and then this is 4y squared. Oh no, I don't want to do... I don't want to do the quadratic formula. It's very tedious. But I guess what we can do is say 4y squared plus 2y, whoops, equals 35. And then I guess 2y here, y here, and plus 1 equals 35. Well, this is easily solvable by a positive number, no? The thing is, we don't know what y is. Y could literally be anything. What if we tried isolating y though? Just leave y to its own. You know what? Let's try that. Let's leave the couple of y's here first. 3y squared plus... Oh no, let's turn that into 4y. 4y squared plus 2xy equals 36 minus x squared. It's mostly just gonna be this trial and erroring stuff. The stream. We could also extract 2y from here. Turn this into 2y. Turn this into 2x. Right? No, just x. So this is x. And this is 36 minus x squared. I'm already lost again. Because it could literally be anything, right? I'm losing it. Whatever. Let's not go down that path for now. And focus on this. Because I think we're already really close to this one, I think. We could make it so that it's y plus 1 equals... Divide this by 2, which is 17.5. So yeah, y is positive, right? There's no way it's not. Right? Y squared plus y. This is so bad. I don't want to do quadratic formula. Okay, I might have spoken too soon earlier. This one, I actually have no idea how. It's just not any possible number. Like, what would happen if we replace this by 2 perhaps? So this becomes 4. Also 4. And then 4 again. So we could extract 4y from everything. You know what? Now I'm curious. What if we say that x is equal to 4? Or no, x is equal to 2. So that would be 4 plus 4y plus for y squared, this looks pretty. Just a barrage of 4s. Special 4s. Oh. We can do this too. So for y, and then just leave it so that it's 1 plus y. So we're kind of in the same boat again. 36, yeah. This time we can divide it by 4 and say y times the sum of y plus 1 is equal to 9. Yeah, it can literally work with whatever. Oh, but I am kind of noticing that the right hand side lowers as we increase x. So maybe it's inversely proportional. As x increases, y decreases. I'm not sure. Oh wait, no, plus it's 63, not 36. Where the heck did I get 36? It's 63. 63, this becomes 62. I'm just gonna erase it sloppily. 36, 63, 62, and then this would be 62, and this would be 31. 31, there we go. But still, I honestly have no idea. They both can be positive integers regardless of what the other value is based from the options. That's all of what I'm getting actually. Okay, now it's starting to pick up the difficulty. Yeah, I'm sticking to A on this one just because it's a safe answer. Suppose y equals f of x has the following graph. Which of the following is the graph of y absolute value of x? Interesting. So if... Whoa, wait. I actually don't know how to think about this. It's gonna treat it as if it were still positive. I think C is the right answer, no? It's so interesting. Why am I getting tripped up by this? Okay, B is just the absolute value of f of x, not just x. E is just the negative version of it. So immediately not B or E. D just put it up. Okay. Just subtracted values from y. A just shifted it. So yeah, C, it's C. It's more of a common sense thing, I think, rather than an actual question. But yeah, wait just a second, I just removed something. Wrong answer. Well, whatever. I'm doing this just like for me to stress my brain out. And I'm also not gonna look at chat that often as well to avoid backseating. But yeah, most of these are guesses anyway. I'm not that good with math. Anyway, number 13. Suppose A and B are positive numbers, such that A squared minus B squared equals 2AB. Equals 4 times the sum of AB. Yeah. You can also try solving some of these stuff. I got this specific set of questions from I'm not sure if they credited here, from LSU math contest, Louisiana State University, if I remember correctly, the 2019 Louisiana State University. And I think this is just their like practice sheet. But yeah, I just thought it'd be fun to try out on stream to see if I still have it, because I just recently graduated from high school. But yeah, and to be honest, I enjoy I enjoy doing math. So you know what? I thought, why not? I'm gonna do this on stream. And here I am. My head honestly hurts. It's really hot. And I'm getting physically tired. No way, it's Shark. No, it's Jeff the Shark. What the heck? So I love math. Yeah. I may not be good at it, but I enjoy doing it somewhat. Welcome to the chat and channel as well. Adrian and Shark the Jeffrey. I'm just Variety, but you can call me Jay. And for this stream, I'm not going to be looking at chat that often to avoid backseating. I may look at it every now and then, but not to find answers. So yeah, just casually competitive math solving. Yeah, that. Anyway, such that find A. Okay, now I'm pressured. There are so many people here. But yeah, I feel like I should know how to do this. A squared plus B no, A squared minus B squared should just be A plus B times A minus B. There you go. Equals 2AB. 2AB. What should 2AB be? I feel like this is so familiar. Oh yeah, it's the middle of A squared plus 2AB plus B squared. Yeah. Yeah. Why am I like double guessing? Right, but I kind of forgot what happens if it's negative sum of differences. It becomes negative AB, negative AB, negative 2AB. Okay, so it doesn't really change. Oh, wait. What we can do right now is this A plus B times A minus B equals 4 times the sum of A plus B. And then we can remove both of these and then just say that A minus B equals 4. So now we can substitute that here. Probably, I literally have no idea what I'm doing right now, but that's usually how it goes around here. But yeah, here we go. So A minus B is 4. So we can now say that 4A plus 4B, 2B, just kidding, equals 2AB. And then I don't know what to do from here. I'd probably replace some stuff, like let's say A equals 4 plus B and then do some stuff from there. So let's start doing just that. I have kind of the hunch that this will just give B equals B. Because that's usually how it goes. Or B. And then equals I think I should put them together and then say 4 plus B. There we go. And then we can simplify this. 16 plus 4B plus 4B, huh? Interesting. 16 plus 16. Or no, what am I doing? Okay, maybe it's not that deep. But that is 8B though. You know what? I'm gonna change it already right now. That is 8B equals... Oh, speaking of 8B, plus... Oh, we have a square. Huh. 2B squared. Oh boy. We can remove both of these. And then just say that... Oh, B squared equals 8. And it's not a perfect square. That's not something that I like to see. But anyway, this gives us information that this is 2 plus or minus... Right now. plus or minus 2 square root 2. That's as much information as this gives us though. And I'm not sure which one to grab. What if we grab the positive one first? Okay. Yeah, let's try inputting the positive one first and then checking the equalities if they still work. Because if they don't, then that probably means we grabbed the wrong equality. But yeah, with B being that, and then we're taking the positive, A is gonna be 4 plus 2 times square root of 2. So let's see. 2AB twice these. Oh my gosh, this is confusing. Let's start the A squared minus B squared first. A squared, if we square this, A squared equals square of 4 plus 2 times square root of 2. We could just say this is 16 plus 4 times 4 times 2 squared, or like 16 square root of 2. I have no idea, bro. But yeah, and then this should give us okay, what? Okay, I'm getting confused. This is I'm like blanking out. This is so bad for me. I'm like losing touch with what I'm thinking. But yeah. Wait, there are already answers the next time? The next one? Wait, what? Questions 14 to 24, exact answers. Oh, so like we need to put the exact answers. Okay. I'm all over the place. Okay. Mental reset. We could express this as the square root of 8. Squaring that would mean that we get 8. Okay. Combine like terms, or we could separate stuff. We could separate the 2's. Or no, we could separate it like this. So it becomes 3 plus 2 root 2. There we go. So this is A squared. B squared would be 8. So minus 8. That looks bad. Yeah, I think I'm sticking with this. So minus B squared. A squared minus B squared. That actually gives us a clean answer. 16 plus 16 square root of 2. Cool. Now let's start computing for 2AB. 2AB might be harder though. If we say that B is positive 2 times square root of 2, then that would give us... You know what? I'm gonna use square root of 8 for now. So 4 square root of 8. This is B, by the way. Oh no, this is AB. This is AB. I should write that down. AB equals 4 times the square root of 8. Or no, what am I doing? 4 times 2 equals 8, and then square root of 2, and then distribute that to the other part. And then that's gonna be square root of 8 times square root of 8. That's just 8. Okay, there we go. Nope, they are not equals actually. It's a matter of fact. Oh no, we have to multiply this by 2. So it works. So it is positive. Kind of want to test the negative one now too. But you know what? No. Since the positive works, I'm sticking with the positive. Oh, but we're finding A though. Oh, We were just supposed to be finding A. I got too lost in the sauce again. It's B. This is 4 plus square root of 8. Oh my gosh. I always lose track of what I'm supposed to be doing. Okay. Well, that was fun to say the least. 14. We've already been taking up 2 hours. But yeah, now we're on the exact answers part. These next 11 questions require exact numerical or algebraic answers. Handwritten exact answers must be written on the answer sheet with fractions reduced, radicals simplified, and denominators rationalized. Improper fractions can be left alone or changed to mixed fractions. I think I'm just gonna leave them at improper fractions. I honestly don't like how mixed fractions look like. They're confusing. Do not make an approximation for pi or other irrational numbers. Answers must be exact. Large numbers should be multiplied out, i.e. do not try to multiply out. Large numbers should not be multiplied out, i.e. do not try to multiply out 20 factorial or 6 to the 40. With that being said, number 14, our first of the 11 questions. We're almost there, brain. We're almost there. I can already feel my brain. In a certain 3-2-1 course, an athlete must cycle 3 miles, then run 2 miles, and finally swim 1 mile. He can cycle 4 times faster than he can run, and he can run 3 times faster than he can swim. If it takes him 32 minutes less time to cycle... Oh my gosh, wordplay at my head. If it takes 34 minutes less time to cycle 6 miles than to complete the 3-1, how long does it take him to complete the 3-1 course? What? I'm so lost. My head. My head. I legit yawned because of that. Okay. Let's break this down. So, you can cycle 4 times faster than he can run. And you know what? Let's make it so that C is cycle, R is run, and then S is swim, CRS. Oh, whoops, sorry for that. That was my other chair. You can cycle 4 times faster than he can run. So C equals 4R. And he can run 3 times faster than he can swim. So R equals 3S. If it takes him 34 minutes less time to cycle... What? If it takes him 34 minutes less time, so does it take him negative 34 minutes? What? Wait, if it takes him 34 minutes less to cycle 6 miles? Huh? Wait, if it takes him 34 minutes less than time to cycle 6 miles than to complete the 3-1, how long does it take him to... Okay, so it takes him 34 something. Takes him 34 minutes less time to cycle 6 miles. Okay, so I'm going to label the athlete course A. So the time it takes him is A to complete the 3-1 course. And this is equal to him cycling 6 miles. So let's say C is 6. Okay. So for this one, C is 6. So how long does it take him to complete the 3-1 course? There's only 3 miles here, but he doubled here. And we know that C equals 3. My gosh, bro. So let's huh? Let's probably put this expression into terms of swimming first, because swimming is our smallest unit. Okay. So he finishes... Man. C is equal to 12S. Right? Oh my gosh. So he swims... He cycles 12 times faster than he swims. If it... Huh? 15... 16, 17... What? 17... Are there options? Please tell me there are options. I don't think there are, but... Right now, I'm just hoping. There are no options. I'm just gonna say 17 minutes. I just literally have the time. I don't even know how to express the answers, but sure. 17 minutes works. Let's just say he's faster at finishing the 3-2-1 marathon than I am finishing this question about him. Why don't we just say that? Yeah, next. 15. Suppose XY is on the circle of radius 4 centered at the origin. Okay, what is the largest possible value of... Huh? Oh, so we can only choose X and Y values from the circle X squared plus Y squared equals 16. Okay. So we have a circle, it's X squared plus Y squared equals 16. This is our circle. Situated at the origin. What is the largest possible value for this? I'm gonna say it's probably when both of them are at their largest. I'm kind of tempted to derive this just to see where the maximum is. But right now, what I also kind of want to do is just find the 45-degree angle of this, the 45-degree of both of them. So just how would I do that though? I don't know what X and Y are. Huh. Interesting. Oh, we could say that they are equal to each other and then say this so that X squared becomes equal to 8 and then X is equal to root 8. I'm not doing the 2 squared 2 thing again. What's the largest possible value for that? Why don't we just replace all of this? Oh wait. We can actually break apart the formula because we have X squared plus Y squared here. We can also probably group some of these. X squared plus 6x. I'm gonna space that out for a bit. Or Y squared plus 1. Now this is where the dilemma is. I kinda need the Y squared to be on its own. Huh. Mamma mia. There's also no Y squared. No, there's no Y term. Just the Y term. That's the largest possible value. It's gotta be at least 1, right? Gotta be at least 1. At least 1 based from this. The plus 1. But wait, I was honestly trying to figure this one out. But now I don't know. Because we could say that this is like plus 3. So then this would be... I'm like completing the circle right now. I'm like super desperate. I don't know what I'm doing. The X squared plus 4Y squared looks awfully familiar though. So I'm super tempted to just say at least 16. Well, technical... Oh wait, it said exact answers. I can't say that it's at least 16. But I don't know. I honestly don't know. Radius of 4. 6x. This is hurting my brain. I'm gonna leave that for now, and I'm gonna start numbering a bit, and then start answering the other questions for now. After this, I'm gonna need a well-deserved break and probably some medicine for headache. Oh, and I still haven't answered this one yet, the number 3. But yeah, I'm gonna move you guys here for now. Yeah, because I have no idea how to take on you. Next question. At a certain food fair, a game of darts is played with a board that is 3x3 square grid. That is a 3x3 square grid with 3 color regions, red, blue, and yellow. If a dart lands on red, you win 5 apples. If it lands on yellow, you win 1 apple. If it lands on blue, you win nothing. You must donate an apple for each dart you throw. Suppose your dart throwing ability is such that your dart always hits the board, and I like how it needed to clarify that. It's the board, and it is equally likely that it lands on any square. You come with a basket of 9 apples and purchase 9 darts with them. After throwing all of your darts, how many apples can you expect to walk away with? This is just probability. Yeah, there are 9. There is a 1 in 9 chance you get 5. I'm gonna write this better. There's a 5 in 9 chance you get 1. Wait, I think I made this wrong. Wait, if it lands on yellow, you win 1 apple. If it lands on blue, you win nothing. Okay, so yeah, blue is nothing. So 3 times 9, you have 0, and then we just add all of these up. We can expect to leave with 10 over 9 apples. Right? Yeah, I think that's how this goes. But after throwing all of your darts, how many apples can you expect to walk away with? There's no way you're gonna win like 1 apple and 1/9 of an apple. So I am kind of tempted to just round down. If a dart lands on red, you win 5. Whatever. I'm just gonna go use the safe bet and just do that. It's kind of cheap, I know, but sometimes in our school that is allowed. Not all the time though. In competitions, I don't think it is. So I'm just abusing. Oh yeah, this is definitely something we did. So I'm also gonna put it here. Moving on. Rectangle ABCD is inscribed. Rectangle is inscribed in a quarter circle with a radius of 6, with AD and DC lying on a radius. Okay, following so far? See the diagram below. Suppose that line AD plus line DC is equal 8. AD and DC are 8. Okay. Find the perimeter of the shaded region. Okay. I don't know. I have no idea why I spoke like that while I was reading that. I was kind of walking the line of having a headache and being like okay. And being confused as well. But yeah, let's copy that real quick. This is A. This is... I'm gonna draw the A a bit bigger. A, D, and then C. Oh, wait. I forgot B exists. My bad, B. But yeah, the radius is 6. So this is 6. 6 units. AD plus DC equals 8. I think we can express it so that... Oh wait, no. We can say it so that we can just write R equals 6. Yeah, okay. So we have what? R minus AD R minus... What? AD plus DC equals 8. AD plus DC equals 8. Find the perimeter of the shaded region. This is gonna be difficult. Oh my gosh. But I think what we only need to know is obviously... Wait, we can already solve part of it. This part. By saying, okay, so it's gonna be pi... 2 pi r actually. And the r is 6. So that's 12 pi. And divided by 4, 3 pi. There you go. So the perimeter... Peri equals 3 pi plus, because this is 3 pi. This we have to kind of figure out, as well as this, and I guess this one too. But where do we go from here though? We do know that... Oh wait, BC, R minus BC is just this. Okay, maybe we should write some of this stuff down. So like R minus AD plus R minus DC plus the diagonal as well. How do we get the diagonal though? I guess what we can do is AD squared plus no, the positive square root of AD squared plus DC squared. We're just Pythagorasing this right now. This can be solved by us figuring this out though. You can also combine like terms. Make it so that it's plus... Oh wait, Oh wait, it's just 6. Why'd I even put R in it? But okay. So 6 minus AD plus 6 minus DC. And what is that? Oh, we can actually... We can do something so that it says... Wait, what? Radius is equal to 6. Yeah, I mean... I feel like there's certainly a way to extract some of this. Okay, what if we did this? AD is equal to 8 minus DC. Right? Okay, let me just label some stuff. I need to separate these because it's confusing me. So that's this one, and this is this one. And I'm not sure if I should even label this. But this is this one. There we go. Now our notes are super messy. More messy than it already was. Earlier I said that there wouldn't be a timer for this stream, but me needing to eat lunch might be the timer for the stream. I just got up from my chair because it just got serious. But yeah, let's try this. If we say that... You know what? I'm gonna remove all of this for a bit. Yeah, I'm gonna remove all of this for a bit. Maybe not this one, this part. Yeah. I'm gonna just label this lowercase a, lowercase b, oh no, lowercase c. So that now I can say AA is equal to R minus AD. Yeah, R minus AD. And we can say that R is 6. We've established that. And we can also move some stuff around and say that AD equals 8 minus DC. So now we can say that 6 minus 8 plus DC is the measurement of AA. And that gives us -2 plus DC. So DC minus 2 is what AA is. I don't know. I've been seeing a lot of these problems on my YouTube recommended back then, and I never watched them. Now I'm kind of regretting it. I probably should have watched them. It would have been worse if I had this in an actual competition, and then I would just go back and forth in my head. Like, I could have watched how they did this, but I didn't. But anyway, let's see. Let's see if we can figure this out. And speaking of seeing, let's try seeing what CC is, what the value for CC is. Wait, it's just gonna give us the same answer actually. Well, CC is R minus DC. And we can say that DC is equal to AA plus 2. So let's try that. 6 minus AA minus 2. There you go. And then this is 4 minus AA. That's CC. You can probably replace this now too. Probably make it so that 4 minus CC. I have no idea what I'm doing, if I'm gonna be honest. 4 minus CC, right? Wait, no. They're gonna swap. So this becomes positive AA equals 4 minus CC. Yeah. So this becomes 4 minus CC equals -2 plus DC. I think I have to find a way to express stuff in terms of the radius. Right now I'm just making this more difficult. But anyway, let's move on here. We can say that now it's 6 equals DC plus CC. We literally have accomplished nothing. We just rewrote this equation again, saying that the radius is equal to DC and CC. Apologies for that. Just had to talk to someone. But yeah, we did absolutely nothing here though. We just restated this statement. I think what we have to do is you could probably make a diagonal here, but I don't know what we can build off of that. We can also find that what this measures to be. What can I do with this information actually? 8. Okay, let's remove all of these again. What was written here again? AD minus. That might be useful. AD equals 8 minus DC. I really think that we have to make something happen here. AD plus DC. We know that AD is R minus AA. What if we try that? R minus AA, that's a measure of AD, equals 8 minus DC. And we know that this is 6, so I'm just gonna rewrite it like that. But now I don't know. Now I don't know. It could be -8 and then AA minus DC. Or we could flip the signs and say that 2 equals DC minus AA. This kinda doesn't help though, because it's this minus that, which is two different things. DC. I'm stumped here actually. This is taking up a lot of my time. DC minus AA? DC minus AA. Wait, that also doesn't seem right. Because I feel like AD should be longer than DC. But I need not to base it directly off of the diagram. Diagrams are never 100% accurate. They're just there to like imprint the idea in your head, and then you're free to manipulate it yourself. But yeah, what do I do from here though? Wait, AD plus DC, it's that one. I thought it was ADAC. I'm starting to be so lost right now. So how do I do this? These are 8. What should this be? What if I had an idea? What if I doubled the radius and then subtracted 8 from it? Because that's this one. But what does that do though? So we're just saying 12 minus 8. 12 minus 8 is 4. So AA plus CC equals 4. Right? That should be true. AA plus CC equals 4. But now what? Now what? DC equals 8 minus AD? Huh? Absolutely have no idea how to tackle this. It's at least 3 pi. I'm just gonna go with joking that it's at least 3 pi. I don't know. I genuinely don't know. Or at least my brain is starting to give up. I really can't. It's so hot. The heat is giving me a headache. Anyway, 4 circles are arranged as in the diagram below. Neighboring circles are tangents. How many paths are there from A to B along the arcs of the circles if you are not allowed to meet any tangent point more than once? Okay, this one is kind of more on the logical side, so maybe I can think of one here. So we're starting here and then we're ending here. How many paths are there from A to B along the arcs of the circle if you're not allowed to meet any tangent points more than once? Well, for one, I can think of this. 1. We are just gonna count. And then 2, 3. Okay, there's probably a more systematic way I can approach this. 1, 2, okay, 2, 3, 4, this doesn't work. 4, I forgot what I did. 1, 2, 3, wait, no. 1, 2, 3, 1, 2, 3, 4, 4, 5. Did I already do this? Here's back to counting. 1, 2, 3. Oh my. 1. Okay, well, I'm just gonna write all of them down. 1, 2, 3, 'Just proceed. 4. I could have drawn that better. 4. Oh no, that's a whole kind of worms. 3. Oh wait, what do I mean 3? Okay, 6 right now. After we enter the inside, we can't go back out. Yeah, I think we can start doing this now. So 1, 2. I'm like so lost. I'm like a lost kid. I don't know what to do. Huh. Well, okay, now let's approach from this side. 1. 2. Oh wait, I can't do this. Right? Yeah, so there are only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are only 10 ways to go about this. I locked in on that one, and I'm almost 100% sure that my answer is wrong anyway. Number 19 though, you play the following game with a friend. You share a pile of chips and you take turns removing between 1 and 7 chips from the pile. In particular, at least 1 chip must be removed on each turn. The game ends when the last chip is removed from the pile. The one who removes it is the loser. It is your turn, and there are 2019 chips in the pile. How many chips should you remove to guarantee that you win, assuming you make the best moves until the game is over? What? For sure we divide this by 7, right? What the heck? I think okay, so it's not always your turn. What if we divided it by 2 actually? So 2 divided by 2019, because half of it is gonna be your turn. What? I have no idea how to tackle this. What? How many should I remove? Well, the first couple of games don't even matter anyway. The first couple of grabs. How many are we? With a friend, so there are just 2 of us. So let's think about this. What if there are 1, 2, 3, 4, 5. I forgot. Oh my gosh. What's the remainder of 2019 would be divided by 7? Hello, Jacob Reynolds. Watch as my brain melts. It's already melting anyway. And yeah, here are my answers if you wanna go back. I like can't even. Yeah, I know. Like I can't even commentate or catch you up on anything now. My brain is starting to slow cook itself. You know math? Then I'd like to see you have a go at some of these questions as well. You can always go back to re-watch the stream. But yeah, credit for the exam that I'm using though is from LSU math competition, specifically their 2019 questions. LSU, I think, is Louisiana State University. So yeah, you're free to try this out on your own. And let's see if you did better than me. You probably will. My brain is melting. It's so hot here in the Philippines. The heat is giving me a headache. Thinking is giving me a headache. But I am a bit already experienced on math competitions. So at least I have that going for me. But other than that, oh my gosh, I am not in the best condition right now. Like, this is such a bad way to represent this is such a bad Just Variety J math competition rep. This is so bad. I promise I can do better. It's been hot out here. Yeah. Like in the Philippines, I think it's like around 32 degrees Celsius, but it feels like 37. Like I'm losing it. Wait. You know what? I'm just gonna do the cheap move. I don't know how to get the answer for this anyway. 8, I think. I don't know. I'm drawing a blank on some of these now. The first couple of ones were a bit easier, but this one is just frying me. Questions, what was it? 14 to 24. Yeah, there's something else. Oh my gosh. Wait, I messed up. That's crazy. Wait. No, I didn't. I just messed up multiplying. What? Yeah, it's 56, not 54. So that means this should be 5, 9. And then this should be 56 again. Remainder of 3. I don't know, just a random guess, probably. Or we could just have it 10, 1000 something. 1000. Like 1009? I have no idea. Wait, it's our turn. So it's not 1009. Assuming if there are 8 left, then we should grab. Oh no, you know what? Whatever, 1009 it is. 1009, and moving to number 19. Wait, didn't I write my answer? Oh, okay, my bad. I placed my answers wrong. There we go. Totally legal on a competition. Anyway, number 20. Or no, 19. You play the following game with a friend. You share a pile of chips. What? Oh, 20. My bad. 3 non-overlapping circles of radius 2 sit on a 4x12 rectangle. A diagonal is drawn. See the diagram below. Find the area of the region shaded blue. That is, the area of the region in the lower triangle, but outside of the circles. Bruh. Is it like... No, I don't think it is. I was about to ask, is it safe to assume that the circle on the left and the circle on the right together just count as one circle, and the one in the middle just counts for half? Well, first and foremost, let's calculate the triangle of the area of the triangle, of the area bounded by the diagonal and the rectangle. It's gonna be divided by 2. It's 24. So the area of the triangle is 24. 24 units is the area of the rectangle. And then we can compute the area of the circles, which is just... Oh no. This is the area of the triangle. There we go. And then the area of the circle would be pi r squared. R would be 2, so it's 4 pi. And then half of it would be 2 pi. And then we'll just subtract it from here. I feel like this is a bit too easy. Come on. Surely it's not that easy. Watch me get it wrong though. So the area of the shaded area, I'm just gonna do that. It's going to be 24 minus 6 pi. Yeah, I think it's safe to bet that this is the answer. I don't know, just going off of gut feel. There you go. I'm not even gonna bother actually writing it for myself because I don't think there's any other play to this than that. Yeah. Surely. There's no way. I'm gonna take the gander for the trade-off that I rest my brain off easy today. Just when I thought that Rusty Lake or Cube Escape Paradox would have had my brain, but nope. This might actually just be the most brain heavy stream that I've done so far, or at least in a long time. Anyway, number 21. While taking a hike in the geometric mountain range, you come across Cylinder Mountain, so named because it is a perfect cylinder. William Aston. Astonished, you begin to investigate. You hike around the base of Cylinder Mountain and find that it is exactly a 5-mile walk. So its circumference is 5 miles. At one point at the base, you notice a trail to the top that... What? At one point at the base, you notice a trail to the top that wraps one time around the outside of the mountain. The trail sign says the length of the trail is 10 miles, and you walk at a constant upward pitch. When you reach the top, you stand exactly above the point where you started at the base. What is the height of Cylinder Mountain? Oh, I get it. Wait, no, I don't. Wait, what? How would that... A trail to the top that wraps one time around the outside of the mountain. Buh? And you walk at a constant upward pitch. When you reach the top, you stand exactly above the point where you started at the base. Kinda hard to understand, but from what I understood, so this is Cylinder Mountain. Weird looking cylinder, I know. And the circumference, I'm just gonna label it with an arrow. Like this. is 5 miles. I'm smart, but you're not this smart. Yeah, I know. This has been beating me up. But I promise the first couple of questions were actually a lot easier than this. So you might have an easier time doing that. Most of these are just guesses. From 14 onwards, these are just guesses. This, I just have the given time. This, I just don't even know. And this one, it's at least 3 pi. Like, I don't even have an answer for 17 yet. 18, and you saw how I did 18, 19, 20. But yeah, and then the trail, from what I understood, was like this. And then this is directly on top of this. And this is 10 miles. So the height is what we don't know. It's kind of hard it's kind of hard trying to determine the height of it. Well, we know that the circumference is 5 meters. I don't know how to compute coils, like the length of coils. Oh. I was kind of tempted to say... Wait. But it only wraps around one time though. So it might look something more like... how do I do this? Something like that? I don't know, man. Like, probably better if we drew it on the cylinder itself. So something like this. And then they're directly atop each other. And this is 10 miles. 10 miles. The thing is 10 miles. So this is 10 miles. Okay. Work, brain, work. I feel like we can probably figure something out here. We walk at a constant pitch upwards? Man, where are the derivatives? That's where I truly shine. I feel like calculus is my main playing field. This isn't it. Where it's like trying to figure out geometry and such. But I guess the way to think about it is I still have plenty to learn, especially in geometry. And one of my other weaknesses actually is money science, or no, money math. And arguably that's probably the most relevant and important math there is. Yet here I am. That's my weakest math. But yeah, I am kind of tempted to say that it's just 2 miles. You know what? Let's take a guess. One in an infinite shot guess. Surely we're correct about this one, right? But yeah, we're moving on to 22. How many squares can be formed from the grid lines in the following figure given all grid lines are equally spaced? Oh my gosh, these questions. I forgot how to do these types of questions, man. First of all, 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7, 8. So there are 6 times 8 or 48. There are 48 plus... We can immediately make the bigger squares. It's actually called an educational guess. Yeah, right. It's a hypothesis. True. I'm scrambling out here, but yeah. Let's try 2 by 2 squares now. We can fit 1, 2, 3, 4, 5. So it's always going to be 5 times 1, 2, 3, 4, 5, 6, 7. It's gonna be 35. Okay. This is 83. Gonna remove this for now. And then now it's time to do the 3 by 3 squares. So it's 1, 2, 3, 4. So it's gonna be 4 times 1, 2, 3, 4, 5, 6. That's 24. In total, this is 107 for now. Now on to the 4x4 squares. I literally have no plan of attack in this. I'm just literally counting. Anyway, 1, 2, 3 times 1, 2, 3, 4, 5, 15. Okay, that's 15 for 4x4 squares. Time for 5x5. Okay, so 1, 2. Thank you, Jacob, for putting math on the TV. Wait, it's kinda diabolical. In the Philippines, it's a common joke. I'm not sure if it's also a common joke in other places, but in the Philippines, it's a common joke that whenever people see math, they just like faint or just get headaches or like they get cursed or something bad happens. It's like a bad omen. So nobody explicitly puts a lot of numbers on boards on big places. But just as a joke. Obviously, when you're teaching at school, you are required. But yeah, anyway, let's go with 5x5 squares. 1, 2 times 1, 2, 3, 4. So that's 8 plus 8. And then 6x6 squares. There should just be 1, 2, 3, 4, 5, 6. 1, 2, 3 6x6 squares. So that's plus 3. And then let's add these up. 122, 133. Yeah, there are 133 squares. I'm just labeling my answers. It's not 133 melons, not 133 cats, not 133 anything else. It's 133 squares. And I guess I should also add units here. 24 minus 6 pi square units, because it didn't say what units it was. Oops. And this one, it's 1009 chips. I forgot what this was supposed to be. I'm just gonna leave it at that. This is, I think, a perimeter thing, so I'm just gonna say units. This one was apples, I believe. So there you go. We labeled everything. So I may be wrong in all of my numerical answers, but I still have the spirit. I labeled all of my answers. Now it's in your room. Whoa, so this is your room? I'm just kidding. But yeah, number 23, last two. Oh my gosh. I'm just gonna take a guess at the other stuff that I left blank. But yeah, 23. A circle is inscribed in a square of side length 2. In one corner, a circle is inscribed in a square of side length 2. In one corner of a circle is inscribed in the region outside of the circle but within the square. Find its area. See the diagram below. Couldn't I just like... So okay, here's the square. Here's the inscribed circle. Just pretend that it's inscribed. There's the mini circle. This is 2 units. Nope. And yeah, it is a square, so it's just the same. It is also 2. It's a square. The area of the square would be 4 square units. There we go. And then the area of the big circle would be would just be pi. Okay, because pi are squared and radius is 1. Okay, pi square units. Now what's the area of the smaller circle? Okay, it may be It's maybe a bit harder than I thought. Oh, but one thing I could do is, let's say that this is the center, this is radius, so this is 1, this is also 1. Let's add a couple more here's to continue. In totality, this should be 2 square root of 2, and we can subtract 2 so that we can say it's 2 square root 2 minus 2, because that's only this and this part, and this is a circle. It feels kind of weird actually, because I feel like I'm having deja vu again. I feel like I've done this for the 4th time already. I feel like I'm here doing math. I just finished doing math stuff as well for my scholarship, and I'm here streaming math while Jacob is also here. I'm having deja vu, but I am fully aware that that has never happened before. That this is the first time this is happening. I feel like I'm pretty sure. But at the same time, I have this like pseudo memory of it also happening. Like, what the heck? I guess I could also divide this by 2, so I only get this part out. Okay, so then 2 square root of 2 minus 2 divided by 2. That's a lot of 2. It's just this, the line of this. And then we can divide it by 2 again. That makes it so that the one under is 4. So hopefully there's still space. We can also start separating these now. Minus 2 over 4. So basically 1 1. Okay, 1 no, square root of 2 over 2 minus 1/2 root 2 minus 2. Okay, root 2 minus 1 over 2 equals the small circle's radius, and then just pi r squared, I guess. And if we pi r squared this, it would give us, where's space? Okay, let's square this. Okay, squaring. How do I square the top part though? I know how to square this one, but not this. I guess 2 what is it again? Minus. Okay, so minus square root of 2, the square root of 2, 2 square root of 2, and then 1 square root of 1. There we go. And then 4 underneath. Yeah, I think this is okay. Yeah, this should be okay. And then pi. Just pi. I think this is the answer that we're looking for. I'm not too sure though. So let's just take this and then put that there. Our answer to number 23. Oh, whoops. Oh no, okay, I didn't mean it to also be there. There you go. Because it doesn't fit here. I think this is right. I think. Last question. I'm throwing in the towel for this one. My brain is losing it. Yeah. I want to believe that that's right. Last question. In a certain rectangle, a point is chosen, a line segment is drawn from the point to the midpoints of each of the rectangle and thus partitions the rectangle into 4 regions. The area of the 3 of the regions is given in the diagram below. What is the area of the 4th region, the one shaded blue? This is another case of I swear I already saw other recommended videos that answer this problem, but I have no idea how to solve for this. I wish I watched those videos, but I didn't. Now it's coming back to bite me. But it all is truly my fault. It's my fault that I didn't watch the videos, and it's my fault doing the math stream right now. So I guess whatever. But dang, it would have been nice to know how to play this out, how to figure out how to do this. I don't know. I'm just gonna put a random number. Like what even is this if we added 27, 36, or no, 34, 34. It looks pretty big, so I'm just gonna guess something around 9. Wait, what is it again? 25, 34. It's 34. I'm gonna guess what's a good number to guess? So it's 34. What can we add to 34 that will make it a pretty awesome rectangle? Like 40, we're gonna add 6. Should be at around 10, I think. If we add 10, then the rectangle could have dimensions of 4 and 11. So probably not 10. Could also just be 9 as well. That would give us 43. A weird number. About 11 to make it 45. And then the measurement would be 9 and 5. Yeah, I'm gonna put 11 just because 11. 11 square units. I'm at a loss right now, and I'm just gonna guess here as well. What's the highest value we can have? I have no idea. What's question 17 anyway? I forgot. Oh, this one, the perimeter thing. Well, it's... I'm thinking. 12 pi, 3 pi. I'm gonna guess 6 pi units. What's question number 6 actually? Oh, wait. 16, 15. I might have messed up counting which numbers I did. 15. No, 16 should be the apple one. Wait. So what? Okay, I'm gonna move these here. And I think it's at least 6 pi units. Wait, then what's number 15? Oh, the largest possible. I have no idea. Let's just say at least. What could it be though? At least 16. At least 1 because of the plus 1. At least 1. There we go. And then the answer for number 3. What is that? The coin problem. I'm not American enough to know how dime cent quarter conversion works. I'm just gonna take a random guess. There are choices here, so that makes my job easier. Sure, 25 quarters. Oh, you know what? Let's do one of the tricks that I usually do as well. And that is listing down the answers. And then just using probability to see which one appears more often. And then that's the answer that I choose. How about B? B appears 4 times. Wow, B. How about C? C appears twice. And D appears twice. And E appears once. Okay. If we're going with the most common, it should be B. If we're going with the least common, that should be E. But 27 looks kind of a weird number. So does B. So in the end, I just go with D anyway. Now, the moment of truth. We get to see if my answers are correct. Let's whip out the checking pen. Okay, so let's zoom out. And the file should be here. And that was just one of 3. I just realized it's the open session. There are algebra and geometry session. I'm tempted that I should have done this in the beginning because of algebra. But seeing as how my brain is kind of getting fried already, maybe not because of the geometry. But yeah, let's check out the answers for the open session. That's what we did. E, right off the bat, we got it right. So we're checking. You check with me. Oh, actually, don't look at this. I should have said that before opening this. If you want to try out the test for yourself. But yeah, we got it. I'm also gonna recite it. We're wrong on number 2? Insane. We're also wrong on number 3? I thought it was easy. 4, we're correct. 5, 2. 6 as well. That's a double D and I messed that up. This is C. I'm starting to fall off. No way. And then it's... Oh, I got the last 2 correct. Okay. Now, time for the exact answers portion. 14 minutes? Or no, wait. 46 minutes? How do you even get that? It was 68. I have no idea. 10. What? I could have gotten this if I just removed the 9, but that's how it goes. It didn't even show how it got the answers. And this is 10 plus 3 pi. Yeah, I kind of figured that it would have 3 pi. 3 pi. 18 was 16. 2? What do you mean 2? Oh, as in... Oh, I think I might have misunderstood the question. I think right now that it was asking how much chips should we get right in this very turn. Okay, I might have misunderstood that. So wait, what would happen then though? So if we remove 2 from 2019, that leaves us with 2017. What's the remainder from that? 7. Then 2017. This is 2, 14, 61, 8, 56, 57, also 8. Oh, so that leaves us with 1. That actually makes it so that the last one that needs to be picked up goes to our friend, so he loses, not us. Makes sense. It's too much math. Yeah, I told you. But yeah, number 20. 24 minus 6 pi. Yeah, I thought that was easy enough. But I don't know how to like logically prove why that works though. I only know enough that it looks like it works. It's from hunches. But yeah, 21, 75, root 75 or 5 root 3. Where the heck did I get this answer? 2 miles. Oh wait, no, this was the cylinder one. Wait, how did they get this then? Huh? Sure. I guess 75. That works. But yeah, apparently this test accepts or as an answer. So this answer or that answer. So I was kind of in the right track doing this with the 10/9 or 1 apples. The thing is, that question in particular only had one answer though. 133 squares. I was correct. I just brute forced that. I have no idea you could actually make something work there. And I am wrong here. I was a bit confident on this one, so kind of disappointing that we didn't get this. It's okay. I got other questions that I was low-key kind of feeling that they weren't correct either way. And 24-16, we're short by 5. Okay, now I'm curious. I wanna look at the questions again. Let's see. Let's try probably figuring out why some of the answers were what they were. But yeah. Who is B? Why is 2B? 2T? The robot? The android, I mean? So what happened here? The answer is B. 6.48. Huh? Huh? Well, it's base rate percentage. What was the value of the stock at the end of the day? On a certain trading day, declined. What? Okay, now I'm kind of confused with how the question is worded. On a certain trading day, stock X declined $0.27 or 4% of its value. Oh, I get it. So what we did earlier was correct. We got that the base was we got that the base was 6.75, but it declined by 0.27. So we still had to subtract 27 from this, which would give you letter B, $6.48. Okay, that's a classic. That's such a classic competition mistake as well. Rushing it too much and being careless. That's one of the main things that my past coaches always told me, is to not be careless and read the questions thoroughly, check it front and back from all of the sides, try looking at it from different perspectives, see if there's something up. But dang, okay, I guess I relearned something today. That's so cool to see, to like keep myself on check. Maybe I should do this by myself some other time, just to keep my brain sharp. But yeah, okay, I missed that, but I'm kind of proud that I caught that, because that shows that I was careless. That's interesting. Okay, my past coaches still helping me to this day. That's so awesome. Oh, and the mic one, the coin thing, I have no idea how to even justify that, so I have no idea. Let's move on to question number 9 though. What is the remainder when the answer is B? The answer is 2. Wait, no. The answer is D. 4. What? Why? Okay, I guess. Okay, earlier what I did was the pattern of raising 9 by the powers, and then finding out that the pattern of their ones digit was alternated between 9, 1, 9, and then 1. But the remainders alternated between 2, something, something, and then 2 again. That's why I answered 2. But apparently not. I guess the 1 before it affects it, so I should have probably checked the pattern of 19. Powers of 19. Which should be more accurate, because the place value next after 1, or the 1 in the tens place value, is 0, so it probably won't have too much of an effect. But how would you have systematically done this in a faster fashion? I'm gonna get plagued by this and start looking it up later. But yeah, for number 10, I'm surprised I got this wrong. The answer is dog. 44. I missed 4. I need to go back to the archive for this one. I need to go back to the VOD for this one, because I might have messed up either counting, I think, either counting or solving for the long and short sides of the rectangles. But despite that was pretty fun though. I flexed my brain in a way so that it still works, but not too much that it drained me like in the exact answers portion. And yeah, question 11. Oh, this one I just guessed. I have no idea. Why is it 3? I could also just solve that later, but I'm not gonna do that now. I don't wanna mess with the quadratic formula right now because y is squared. If we substitute in x, then that leaves a lot of y squareds. Or maybe not. No, it does, because if we square the sum of x and y, that leaves 2xy, and it's a whole kind of worms. Or just 6y. But still, the fact that there are two different indices. There we go. I'm forgetting my math terms. The fact that there are two different indices makes it difficult to do that right now without having to do what's it called again? Oh my gosh, quadratic formulas. And these, the exact answer questions, I didn't understand them to begin with, so I don't think I'll understand them anymore now. 15 is 68. Oh my gosh. This I could have actually guessed more on point though, because I knew it had to be at least 3 pi, because this is quarter of a circle and the circumference of the whole circle is 12 pi. Dividing that by 4 gives us 3 pi, so we just have to add what these are. But how did we get that though? I wonder. I actually just wonder. Interesting. But I'm kind of thinking of ideas right now, but they all don't lead anywhere. For 18, the answer is 16. We counted this, so, but I already undid all of the squiggly things I did. I'm just gonna revisit the VOD again later. Wow, so this is actually such an exercise to the brain. I may not have gym streams, workout streams, but I do have mental workout streams. 20 is just a lucky guess on how the proportion of the circles affect the proportion of the parts they remove from the triangle. That works, I guess. This one, the chips that we had to remove, we already looked about that earlier. We figured that, yeah, we only do need to remove 2 right now, so that the remainder later is 1, assuming that all of us just keep getting 7s. Yeah. You play the game with usual. You take turns removing between 1 and 7 chips. The game ends when the last chip is removed. It is your turn. Should you remove to guarantee that you win? Oh yeah, so I think it is, yeah, just asking for this one time. The squares, we just brute force that. This, I have no idea. The fact that it even got a square root. Huh? I'm trying to think. I can't. Like, even the formula for the surface area of a cylinder doesn't help, I think. Oh, wait. Oh, wait, we could have probably made it so that this is a net. So this is the net of the cylinder mountain, and this is the thing that wrapped around it, and then it was directly above where we started. This is 10 miles. And then this was how long again? Oh wait, okay. I think now I can probably take on this. It's a 5-mile walk. So it's 5 miles. Oh, but it doesn't have pi though in it. Probably this is pi. This is 5. Still, how would that work though? Like, if we said that this length here is 5, and then we did this, Pythagoras. Thank you, Pythagoras. Pretty funny. This is 125. Oops. This is 125 minus minus... Oh, wait, no. Equals b squared. So I just had to square root this. It still doesn't work. Even if we remove this. Oh, wait, but it is minus though. Oh, now I get it. Okay. So, yeah. The circumference is exactly 5, and this wraps around the circumference of the circle. Anyways, whatever. We should have just netted out the cylinder. I was having too much trouble even like imagining it in 3D, where we had geometry to flat it out to 2D, where it was more manageable in the Euclidean space. Oh my gosh. Now that's a bummer because we could have gotten that. Oh my gosh. At least now I know. I figured. So whenever we're dealing with 3D, we should probably net them out. But that's interesting. This is what's fun about doing these sorts of like practice competition stuff, because you get to realize like stuff that you got wrong and why they were wrong. It's pretty cool. And what's our other wrong stuff? 23? 23, yeah. Why is the answer 17 minus 12 times the square root of 2 all multiplied by pi? What? This I have to figure out on my own as well, off stream, most likely. But this one's interesting though. I might not need to go back to the VOD for this one, because it feels pretty like, how can I say this, like mental. It's just the idea in your head. And this, I just guessed this and I got 16. Honestly, I'll take it. But what if we add 16 though? So that's 25 plus 16. That's 41. 50. So the area of the rectangle is 50. Okay. I would not have guessed that. Sure, I guess. Sure. I have no idea how you get that. I need to catch up on some probably what is it? I forgot the channel, but the one where he tackles on different math problems. Oh, well, to be fair, there are a lot of channels like that. But yeah, I hope you guys enjoyed. I can't even say that with a straight face right now because I'm sure I suffered. And I'm not sure if you enjoyed me suffering, or you suffered by watching me suffer, or you suffered just from the sight of numbers, a lot of numbers and shapes on screen. So yeah, everyone please take some rest, because I know I will, but I also know for a fact that I will also come back to this off stream, because I'm the kind of person that gets hooked on these kinds of stuff. And now I have an itch to just figure out how these answers got. Also, the first set of math tests that we did, math questions, were way too difficult. Maybe I should also catch up on more complicated and advanced topics, because that's how I won most of my competitions back then. I was just way too advanced. Now the time is finally catching up on me. So yeah, I hope everyone will have a wonderful rest of their day, rest of their day, afternoon, night. Yeah, I'm going to take some rest, and everyone take care as well. It is super hot here. I'm just not sure on your respective places, but yeah, take care everyone. Wait, we scored what actually? I didn't even check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We scored 10 in 24. Let's go. Yeah, quick maths. Literally only took us almost more than 3 hours. No, more than 3 hours and a couple of minutes. So yeah, we scored 10 in 24. How much is that in percentage? 10 in 24. We got a 41, less than 50%. Wow. Insane. And A, B, C, D grading system. If we were graded in letters, we would have gotten... What's our percentage? Oh, whoops. 10 divided by 24. 24, we got 41.66 repeating percent. We gotta fail. Oh yeah, right, outro. Yeah, we failed, we got an F. That's so bad. But speaking of grading stuff, tomorrow our stream will be grading stuff about me again, my old article titles. I'm kind of excited about that because it's been years since I've read some of my past articles. So I hope you guys will enjoy that. But for now, see you tomorrow. Yep, the stream is done. I failed. I need to review. Bye-bye. Thank you, everyone. Take care. Outro. Bye-bye.